Okay, so now what means surface area to volume ratio? So it's actually a ratio. We calculate the surface area divided by the volume. Okay, so the ratio between the surface area and the volume of the cells and of an organism has enormous impact on their biological processes. Okay, so always remember, what is this mean? We always say that in a total surface area to volume ratio is an indicator actually. What's the indicator? It indicates the exposure, how much the exposure to the environment and vice versa. So it means that if we increase the surface area to volume ratio, right? When we increase the surface area to volume ratio, means that we expose more to the environment. When we expose more to environments, then we increase the rates of the diffusions, correct or not? Okay, so that's why the cells tend to be small. Why? Because when something is small, surface area to volume ratio is high, and we're going to calculate it later. Okay. Now, for example, individual organs like lung have a very large surface, okay, to support the gas exchange, bringing oxygen into the blood and releasing the carbon dioxide from the blood. Similarly, our small intestine will have very this fine wrinkled surface. Okay, again, we increase surface area, okay, by using these villi, and also in the cell we have the microvilli. So the cell can achieve higher surface area to volume ratio. How they do this? With the elaborately convoluted surface, for example, microvilli that line the small intestine that we have learned about this microvilli. So the first question we're going to ask here, okay, if we are cruel enough, we're going to put these two, okay, and we have the large freezer, okay. So if we left in the cold overnight, we put the elephants and also the mouse in a freezer. Who will die first? Yes, give me your answer. Think about it. Okay, we should know that when something is small, means that generally their total surface area to volume ratio is high. So it means that more exposed. Are you clear? More exposed. Something large, the total surface area to volume ratio is low, so less exposed. So in this context, mouse will have, okay, in general, okay, will have the high surface area to volume ratio compared to the elephants. Okay, definitely. So means that they expose more to the environment compared to the elephants. So means that who will going to lose more heat energy if you freeze them, right? And both of them will die eventually, but who will be first one and more danger of freezing to death? The mouse. Why? Because the mouse, so means because of total surface area to volume ratio is high, so means that more exposed. So means that more heat energy, more heat energy is lost to surrounding. Okay, so this is the explanation why the mouse will die first, because they have the large total surface area to volume ratio. Okay, so they are more exposed, therefore more heat energy is lost to the surrounding, so they will die first. Are you clear? Okay, but generally elephants, how they actually adapt in this case, you can see that the skin, less fur, cannot. Okay, for mouse they have fur. Then for the elephants, you can see that the skin have a lot of folding to increase the surface area. Okay, so in your syllabus, we need to learn how to calculate the surface area to volume ratio. Okay, my example here, I use A and B, they are cube. So A is 10 by 0, 10.0 millimeter by 10.0 millimeter by 10.0 millimeter, while the B is 5 by 5 by 5 millimeter each. So this is the cube. So what you need to do now, calculate the total surface area, calculate the volume, and what is the total surface area to volume ratio. Okay, and try to figure out what is the unit. Okay. So for A, A is 10 by 10 by 10, right? Okay, so means that total surface area 6 multiplied with 100, so 600. So what is the unit? Total surface area, because the unit is mm, so here will be mm square. Okay, mm square. Volume 1000. So what is the volume? mm cube. Okay, write down the units. So what is the surface area to volume ratio? 600 over 1000, 0.6. Okay, now in your syllabus, you are not required to know the surface area to volume ratio, the unit. Generally, no need to put any unit for total surface area to volume ratio, but this is not so true. Are you clear? Later, I want you guys to figure out what is the units, okay? Try to think about the units, okay? Now, how about B? B is 5 by 5. By 5, right? Mm. Kind of, 5 by 5 by 5. So 5 times 5, 25, multiplied with 6. So it's 150. Okay, millimeter square for the surface area. Volume 5 by 5 by 5. So 125. Okay, so 150 divided by 125. So it's 1.2. Okay, so I stop the recording a while. So a lot of you guys tell me the millimeter to the power -1. If you put in this millimeter to the power -1, what is the meaning of this unit? There's no meaning. Per millimeter, 0.6 per millimeter. What is that? Okay, so in biology, the unit have to be extra careful. So the answer here is millimeter square of surface area per volume, millimeter cube. Okay, the unit is millimeter square of surface area per millimeter cubed. Now, what does this mean? Now, the unit. That's why, I mean, you see, in Cambridge, you are not required to know. This is quite complicated. A lot of students are going to give millimeter per negative, to the power -1, say per millimeter square per millimeter. So the answer here is very clear. Can you see that? What does it mean 0.6? For every millimeter cube of the volume, the exposure is 0.6 millimeter square only for the cube A. Do you realize that? What is the meaning of 0.6? If you say 0.6 per mm, I don't know what you mean. What does it mean 0.6 per length? But the unit here is millimeter square of surface area per millimeter cube, because this one is 0.6 exposed. How much exposed? Exposed 0.6 millimeter square for 1 mm cube of volume, compared to B, 1.2 millimeter square of surface area exposed per millimeter cube. So now you know that this one exposed more, right? Can you see that? Exposed more. Okay. Now I want you guys to highlight another part that students always make the mistake. First, surface area. When you increase the size, always remember we increase the total surface area. This is confirmed. Are you clear? When you increase the size, small size, large size, surface area increase. Correct or not? Right. Surface area actually increase. Students always think, oh, increase surface area. I mean, increase the size, decrease the surface area, which is wrong. But when you increase the size, total surface area to volume ratio decrease. That is correct. Why? Because you can see that there are not much difference, right? Not really a lot of difference, but the main differences here means that when you increase, okay, the size, basically volume increase even more because cubic, right? When you cube it, right? So increase even more. So when you divide something large, not the large value, when you divide something large value, definitely there's the ratio will be lower. Okay, this is something that you have to understand, because question always, paper one always trick the students. Okay, increase the size of the organism or size of the cells, decreases the total surface area, which is wrong. It's a total surface area to volume ratio. Okay, now, but funny thing here is, interesting part here is, when you talk about total surface to volume ratio, you only can use it to apply to the same geometrical shape. Are you clear? You only can apply to a same geometrical shape. You cannot compare surface area to volume ratio by using one's cube, another one is cuboid, or another one is a round shape or spherical shape. Cannot. Are you clear? And you have to understand, okay, if I have a cube like this, compare to a cuboid with a very thin, not thick, very thin. Can I see that? Okay. So what happened here is the diffusion rate will be faster. In this case, it will be higher because they're very thin. So we don't consider the total surface area to volume ratio. So total surface area to volume ratio is just a general guideline. If I do not know the shape, okay, if you tell me total surface area to volume ratio for the solid number 1 is 2.0, and the total surface area to volume ratio for solid number 2 is 1.0, then I know this one will have higher exposure compared to another. That's all. Are you clear? If you don't show me the shape, if you show me a dimension, then I have to take into consideration if they are very, very thin. Even though maybe the total surface area to volume ratio is low, but it doesn't matter because the diffusion will take place with higher rate because they are thin compared to something they are thick. Are you clear? Understand? Okay. So, and the last one, in the syllabus, you need to know. Let me remove. How to calculate the surface area for a sphere and also the volume of a sphere. Okay. So, write down. I didn't put it in. So, for the sphere, volume for the sphere, you should know, right? Equal to 4/3 pi r cube. 4/3 pi r cube. But as usual in biology, can you measure radius? You won't be able to measure radius because you do not know where is the center and it won't be accurate. But if I have the sphere, I can always get the diameter. So you measure diameter, so d/2. Always substitute the r with d/2, the diameter. So it means that if I have a sphere like this, so I can use a ruler, make it a parallel, then I can always measure the diameter. Okay, we cannot measure the radius because we do not know where is the center. Okay, so I change the formula here now. So it will be equal to 4/3 pi d/2 square, and the surface area for the sphere will equal to 4 pi r square, so pi d/2 square. Write down. We need to know these two formula. Okay. One is the volumes, another one is the surface area for the sphere. Then you can calculate. Okay. So with this, I have done for this part, surface area to volume ratio. Now, please go to the checkpoint and try the question because we have a different kind of question that you can learn from that checkpoint. Okay.